All right, college algebra class, these are the notes for section 3.2. We're going to be looking at solving some quadratic equations by the different methods that we have: factoring, graphing, quadratic formula, also completing the square. So we will go through those. All right, so it says quadratic equation in one variable is an equation that can be written in this form, and they didn't really make it should say equals 0, because if it's an equation it has to have an equal sign in it, so equals 0 in that form. A, B, and C are constants, and A is not equal to 0. Okay, so for solving quadratic equations, we'll be looking at solve by factoring, square root property, completing the square, and quadratic formula. Remember that for the solutions, you can either have one real solution, two real solutions, or possibly no real solutions. All right, so factoring. Factoring is a common technique. It's usually the fastest way to get the solution. It's based on the zero product property, which basically says when you get your two factors, and A and B, those would be like binomials. It'd be like x minus 2 times 3x minus 5 or something like that equals 0. And so then what you do is you set each of those factors equal to 0 and solve for x. Because if either one is 0, it's going to be a true statement. So let's take a look. They start us off with, I think one that's maybe a little harder to factor. I just wanted to go back to the basics of factoring, so I just made this one up here. So when we have a leading coefficient of 1, that's usually an easier factoring technique, but let's just look at one of those first so we can just recall the main components of solving by factoring. So for x squared, obviously our only choices are 1x times 1x. Now, when you have that leading coefficient of 1, then you can just ask yourself, what are the factors of negative 18 that add up to a positive 3? And then it's pretty easy to come up with a positive 6 and a negative 3. And what I always would have students do just to check it, so I'd draw that and I'd say, okay, well that's a positive 6x, and this product here is a negative 3x. And then we add negative 3 plus 6, that equals 3, so that works. And you probably didn't need to do that in this because the leading coefficient is 1. However, when we get to this one over here, when we get to this one, it is kind of important to check, that outer and inner product, and that the sum does add up to the middle, because you can't just say, oh, what are the factors of negative 1 that add up to negative 1, because that doesn't really work, because this coefficient is going to come into play here. So we may have to guess and check on this a little bit, but because this middle coefficient is a small number, I think I want to keep these factors close together. So instead of doing 12 and 1 or 6 and 2, I'd probably go 3 and 4. So I'm going to put 4t and 3t. And then I'm going to go with negative 1 times a positive 1. And then I'm just going to make sure that this works out. So if I do this product, that's a positive 3t. And if I do this product, that's going to be a negative 4t. Now I look, negative 4t plus 3t, yes, that equals negative 1t. So I know that that's the correct factoring. Now what I haven't done yet on either of these, now we did get them factored, but we didn't solve them yet. So going back to this one, we know this is our zero product property, so we have to set each factor equal to 0 and solve. So x plus 6 equals 0, and x minus 3 equals 0, which gives me solutions of negative 6 and positive 3. So those are my solutions there. Over here, 4t plus 1 equals 0, and 3t minus 1 equals 0. So then I would minus 1 divided by 4, t equals negative 1/4 for that piece. And over here, add 1 and divide by 3. So I would get positive 1/3. Okay. So again, it's always important to check your outer and your inner products so that the sum of those two will equal your middle coefficient. Okay, your linear coefficient. Square root property. Okay, so this is a pretty easy one to use, but it's only going to work when you don't have that b, when the b is 0, I guess is what I would say. So like if I had, let's say, x squared minus 16 equals 0, then I could just add the 16 over there, and then I could square root, right? And then it would be x equals plus or minus the square root of that number, plus or minus 4. Okay, so it only works to use this if you don't have like a b is 0, if there's no linear term in the middle. Okay, so there is a application problem, and I think we saw this formula in a previous section. So when we have height versus time, and it's something that's acceleration due to gravity, where time is in seconds and feet is the height that we're talking about. So we have this negative 16t squared minus v sub 0 t plus h sub 0. H sub 0 being your starting height, v sub 0 being your starting or initial velocity, and then time in seconds, height in feet. Okay, so it says a metal ball is dropped from 100 feet. Now an important word or verb in there is that it was dropped. If something's dropped, then that means that its initial velocity right here, that's going to be 0, which means basically this middle term gets eliminated. If it's dropped, it's not thrown. If it's thrown, then you're going to have an initial velocity. Okay, so 100 feet, so 100 feet is going to be where it's starting, so that's h sub 0. So I think I can write an equation here. Well, actually, they did that for us. They put in the 100, and they actually just kind of flipped these around, but 100 and then minus 16t squared. So there's our equation. Determine how long it takes for the ball to hit the ground, right? So ending height is your h of t. We've got 100 minus 16t squared. Now hitting the ground means that we're going to be at 0 for our ending height. So we'll put a 0 there. And so now I'm going to take 16t squared, add it to this side. And I'm going to, in order to use that square root property, I have to get t squared or x squared, whatever it is, by itself. So I've got 100 over 16. And now I can square root. And those are each perfect square values, so I get 10 fourths, which is, what, 2.5, 2.5, and that'd be seconds. So it takes 2.5 seconds for that ball to hit the ground. Okay, so we use the square root property to solve. All right, completing the square. This is the one that most students don't use as much because it's, you got to remember some steps that aren't common. Like most of us probably would choose to use the quadratic formula, I think, instead of completing the square. But we're going to look at all these different techniques, okay? And I did in the previous section, I think we did some completing the square to write a quadratic function in vertex form. And so this is similar steps, but in this case, we're actually working on both sides of the equation. In the previous section, we just wanted f of x on one side, so we kept all the work on the right side of the equation. But the key step is kind of the same. All right, now before we can solve by completing the square, which is what they're asking us to do here, the only way that you can do that is if this leading coefficient is a 1. So if it's something other than 1, you have to divide that out. So I'm going to rewrite this as x squared minus 4x equals 7/2. Now, because I divided everything by the same thing on both sides, it's an equivalent equation. Okay. Now, when I use this technique, leave yourself some space after your linear term right here. Leave a little space because you're going to complete the square at that point. Then you always do want the constant. You want to have that over on the other side of the equation. It was already set up that way. Okay, so the completing the square part, that's where I take, this, it's b, I think that they call it k over here. Yeah, whatever, they called it k, but in the standard form it's ax squared plus bx plus c. Usually they say b divided by 2 squared. That's going to create your perfect square trinomial, and you need to add that same amount on the other side. Okay, so if I take 4 let me just do this side work here. When I'm completing the square, I'm taking this linear term right here, I'm going to divide it by 2, and then I'm going to square that like this. So 4 divided by 2 is 2, 2 squared is 4. So as it turns out, a 4 here makes that a perfect square trinomial. I have to add the same amount on this side. Okay, so this is going to be factored into something squared, right? So if I would take x minus 2 times x minus 2, that would FOIL out to x squared minus 4x plus 4. So that's how this factors. X minus 2 times x minus 2. I always know that it's going to be something squared because I've added this number to create a perfect square trinomial here. So that's what I get. And then if I add these two together, 7/2 plus 4, instead of 4, I could call it 8 over 2. So that would give me 15 over 2. Hopefully you're following that. And then to solve, now I apply that square root property because I have something squared on the left side, the whole thing squared, so I can square root that to cancel the exponent of 2. And then I have plus or minus the square root of 15 halves, like that. And then I would go add the 2 to the other side, 2 plus or minus the square root of 15 halves. And that would be, now a lot of books would rationalize this value here. I'm not so concerned with it, but I'm guessing in the homework, if it's multiple choice, they would. So let's say I'd have 15, root 15 over root 2, and then you go like this process, and you get root 30 over 2, right? So we might want to write that as x equals 2 plus or minus root 30 over 2, like that. Okay? All right. That was completing the square. Here they're just going to do a comparison of solving symbolically, which is algebraically, numerically, which is basically just looking at a table of values and seeing, okay, if I plug this in, what do I get? If I plug this in, it's kind of a guess and check method. And then graphical solutions, okay? And they're all going to be involving this quadratic equation. It doesn't look quadratic because it's factored, but if you distribute that through, x squared minus 2x equals 3, so it's quadratic. First of all, the numeric way of doing it, you know, all that they're doing is they're just, well, let's just plug some numbers in here for x and see if any of them give us the solution of 3 that we were looking for. And as you do that, you're like, okay, well, there's an answer. So x equals -1 is a solution, and I keep trying other ones, and then I finally get another 3. So they're kind of guessing and checking and coming up with -1 and 3 as the solutions that way. All right, the other way that you can, or one of the other ways, a graphical solution, and this would probably be something, you know, if you're working with your graphing calculator, you plug in the, you know, this side, the x times x minus 2, which is going to give you this parabola, and then on the other side it was equals 3, so you just put in y2, you'd put equals 3, and you're going to get this line, right? And so we're looking for where does this line intersect our parabola, right? It's going to intersect it at 2 different points, but we're looking for the x coordinates of those points, -1, +3. Okay, so same solutions, different process. And then the symbolic, they didn't really show that, but you know, symbolically what we'd do is, well, you'd distribute this x through, so you'd have x squared minus 2x equals 3. And then you would finish that by probably factoring. It's usually what we try to do if it's factorable. So I subtract the 3 over, have 0 on the right side, and I try to factor this out. And so I get x times x, and then factors of -3 that add up to -2 would be -3, +1. And if I kind of do my little demonstration to show that it works, that product is -3x, this product is +1x, +1 plus -3 equals -2, so that's correct factoring. So x minus 3 equals 0, and x plus 1 equals 0. X equals 3 and -1, which is what we were seeing on all the other methods. Okay, so numerically, symbolically, and graphically. Okay. Last thing we'll look at, quadratic formula. Most of you probably still remember this: x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to talk specifically about the discriminant, which is this part right underneath the square root. The discriminant tells us, the reason it's important is because it basically tells us how many solutions we're going to have. If you get a negative discriminant, that means you're taking a square root of a negative number. There are no real solutions, no x-intercepts. They'd be imaginary solutions. If you get a discriminant of 0, meaning that you're going to be adding and subtracting 0 as part of the process, then that means you're only going to get one answer, because all you're left with is -b over 2a for your x value. So that means you're just going to get the one solution. Graphically, it means the vertex just touches the x-axis. It's tangent to the x-axis. The most typical way would be that your discriminant is greater than 0. It's a positive number, and that's going to mean you get 2 x-intercepts, which is probably the most common that you see. All right, so again, summarizing that, positive discriminant, 2 real solutions; 0 discriminant, 1 real solution; negative discriminant, no real solutions. And I just kind of left the work here to kind of save us a little time. All right, so if this is our quadratic equation, it says use the discriminant to find the number of solutions. So discriminant b squared minus 4ac. So that's -12 for the b, -12 squared minus 4 times a times c. 144, and this ends up being 144. Subtracting, we get 0. So if we have a 0 discriminant, that means one solution. So then we go through and plug that into our entire formula. We already calculated this part to be 0, so I'm just going to put that back in. So -12, the opposite of -12 is +12. So 12 plus or minus the square root of 0 over 2a, 2 times 4. So then we end up with 12 over 8. So 3/2, that would be our solution for that one. And we can see, yeah, we only get one solution because the 2 solutions comes in by adding a number here and then subtracting the number. But if the number is 0, you get the same value if I take 12 plus 0 or 12 minus 0. And that's why you only get one answer. That is it. So You can do the homework on Schoology for this section.